Here's a problem from WebWork. The answers are already here. I want to show you how I found those answers using R. The first thing to do is to understand what the problem is talking about. This first question says, suppose that we've got a normal distribution and we want to be within 1.22 standard deviations of the mean. That means we want to be 1.22 standard deviations above the mean and a minus 1.22 standard deviations below the mean. So what we're going to do here is standardize the normal distribution, have a mean of 0 and a standard deviation of 1, so that this x-axis is just measuring the number of standard deviations we are away from the mean. Then this blue area, the area below 1.22 standard deviations, could be calculated by the pnorm. Pnorm 1.22 in a normal distribution that has a mean of 0 and a standard deviation of 1. This red area could then be calculated by the pnorm of negative 1.22, mean of 0 and a standard deviation of 1. Then the area that we want, the area in between these two, that's this yellow area right here. Okay, okay, so that's clumsily colored in. That yellow area is going to be the blue area minus the red area. So let's get R to do that particular task for us. Let's discard that. So here's R. And I want to find the pnorm of 1.22 in a distribution that has a mean of 0 and a standard deviation of 1. That would be that blue area, the area below 1.22 standard deviations above the mean, minus pnorm of negative 1.22 in a mean equal to 0 and a standard deviation equal to 1. Okay, so there's that particular calculation. Let's just think of the other calculations real quickly. I want to be 3.5 standard deviations above the mean and a negative 1.5 standard deviations below the mean. So it's a matter of looking at a very similar calculation here, except the above the mean part we want to have the below the mean part is a negative 1.5 standard deviations below the mean. We want to subtract that from 3.5 standard deviations above the mean. So we're doing the pnorm of 3.5, mean of 0, standard deviation of 1. So that's 3.5 standard deviations above the mean. We're going to subtract